What up, everybody? InstructaBeats back again with our linear equation playlist. This is linear equation playlist video number 7. Today we're going to be taking a look at unique solutions, no solution, or infinite solutions. So let's get on that train and let's get on moving. So our objective today I will be able to recognize if a linear equation has a unique solution, no solution, or an infinite amount of solutions. Let's take a look at some mathcabulary to find out what does that even mean. So our mathcabulary, right? Everything that we have been doing so far in linear equations, you've been able to find a solution for, and when you checked it, the equation was balanced with the solution that you found. And that's what a unique solution is. A unique solution is when an equation only has one answer for x that will make it balanced. Everything that we have been dealing with so far in our linear equation playlist has had a unique solution because only one number made the equation balanced, made the expressions on either side equal to each other. So you know that, but we haven't labeled it yet. So we're going to label that as a unique solution. No solution obviously goes along with the name of the mathcabulary term, no solution. That's when an equation does not have an answer for x that will make it balanced. So you've simplified it all the way down, and nothing you can do to it is going to make those two expressions balanced to each other, right? And so we haven't dealt with any of those yet, but we're going to look at an example. And then we have an infinite solutions option as well, and that is when an equation can be balanced using any number for x. Any number will do, it will work, no matter what you do to that equation, no matter what number you plug in, the scale will be balanced. The two expressions will be balanced on either side of the equal sign and be equal to each other. So this lesson is going to be a little bit different. We're not going to have an I do, we do. What we're going to do is I'm going to show you 3 different equations to give you 3 different examples of our mathcabulary. And then we're going to have 2 we do problems that you're going to solve and try to figure out, okay, does this equation have a unique solution, no solution, or an infinite amount of solutions? So this first one is just like all the other ones we've been doing, right? We know we have our equal sign here, which means our 2 expressions on either side should be balanced or equal to each other, which is why we use that visual of a scale right here, right? We have coefficients, variables, and constants, and we're going to follow our same rules just as we have before. And so the first thing I want to do is my distributive property. I don't have any. Now I want to isolate my variables. So I'm going to make a 0 with this 5x by doing the inverse operation of positive, which is negative. So that's going to cross out, and I'm left with 2x minus 3 equals 5. And now I want to make a 0 in this expression by adding 3 to my negative 3. Whatever I do to one side, I have to do to the other. And now I'm left with 2x equals 8, right? And so my inverse operation of multiplication would be division. So I make a 1 right here, which gets rid of my fraction. Then I have x equals 8 divided by 2, which is 4, right? And so I think I have a unique solution of 4, but just as always, I want to check. So I'm going to have 7 groups of 4, right? Minus 3 is going to equal 5 groups of, 4 plus 5. So 28 minus 3 equals 20 plus 5, and I have 25 equals 25, right? So my check is correct. Thank you for the applause, always appreciated. So this is a unique solution because there is only one solution that works to keep our scale, our equation balanced, hence the name unique. Let's take a look at it. The second mathcabulary word. So before we start solving this equation and simplifying our 2 expressions, something I want to point out right here is that my variables are the same on either side, but I have different constants. So go ahead and kind of jot this note down somewhere in your notes. No solution is going to typically have same variables on either side, and right, so in both expressions, but different constants, right? To be honest, I don't even know if that's how you spell different, but who cares? We're doing math, not trying to spell, right? So I'm going to go ahead and solve this out, but notice these two things, and it might save you a little bit of work down the road. So first thing I want to do, I'll get rid of my 3 over here, and whatever I do to one side, I have to do the other. So I've made a 0 here, and now I have 7x equals 7x plus 8, okay? So this is why it's important that you kind of notice that there are the same variables but different constants. Because if I'm going to take away 7x here to make a 0, when I take 7x away from here, I'm left with nothing, and 0 does not equal 8, right? So I don't even have a variable to solve for because when I made a 0 over here, I accidentally made a 0 on the other side as well, which is why it's important. If you have the same variables, they're both positive 7x's, when you go to isolate those variables, there's going to be nothing left. So kind of pointing out a characteristic or a character trait, get some reading in, of a no solution linear equation, right? And so this will never have an answer. There's never a solution that's going to make this work because when I went to solve it, I got rid of all my variables. I had nothing left, and 0 does not equal 8. So here we have an example of a linear equation that has infinite solutions. And when I think of infinite, obviously I think of Buzz Lightyear to the rescue. I think that's how it goes. Haven't seen Toy Story in a while. Great movie though. I do recommend it. Okay, Disney is not giving me any money to say that. Well, if you look right here, if we started to kind of look at this linear equation, what we notice about this infinite solution is the variables are the same, right? They're both positive 7x, but on top of that, the constants are also the same, okay? So on either side of our equation, and you can go ahead and jot this down. I'll kind of put a line right here to help us out, right? On, on each expression, we have the same variables and same constants. Now, obviously, I hope you can see where this is going, where this is going to be a problem, but let's go ahead and solve it out. First things first, I'm the realist, and I'm going to move that over, okay? And so, obviously, I want to get rid of this, and when I get rid of that, I'm also going to be doing the same thing on the other side. So I made a 0 by adding my positive, and I'm left with 7x. Oh, and I accidentally made a 0 here as well. So 7x equals 7x. When I divide by 7, whatever I do to one side after the other, so I've made a 1, and now I have x equals x, which means no matter what number you put in for x, you're going to have to put it in for the other x, which means it will be equal to each other. If x is 2, 2 equals 2. If x is 5, 5 equals 5. If x is 1 half, 1 half equals 1 half. If x is 1 trillion billion thillion, then the other x is 1 billion trillion thillion, and they're equal to each other, which means we have an infinite amount of solutions. You can do any number here, and it works. Now, some of you might be thinking, Mr. InstructaBeats man behind the microphone, what if I got rid of the variables? Good question. Let's look at that. So I'm going to rewrite this over here to keep both examples, okay? And some of you are thinking, okay, well, what if I didn't start with my constants? What if I started with my variables? So if I subtract 7x here, right, to make a 0, whatever I do to one side, I have to do the other side. Obviously, these are going to cancel out, and I also made a 0 over here, so I have negative 3 equals negative 3, okay? Now, if you notice, the misconception might be that x equaled negative 3, but there are no x's left. They're gone. So negative 3 will equal negative 3, right? Which means no matter what you put in for x, they were going to cancel out anyway, and you'll always be left, if you do this way, with negative 3 equals negative 3, which again makes an infinite amount of solutions. We've had 3 different types of solutions. We had our unique solution. We had our example of a no solution where the constants were different but the variables were the same. And then we also had our infinite solutions where the variables and the constants are the same on either side of the expression. Let's get on the train and do a couple we do problems. You can check it out. So here we have a we do problem, right? If you're ready to try this out, go ahead and you can pause it, solve it, push play, and we can check it with you. If you're not there yet, go ahead and you can just solve it with me, okay? So the first thing I want to do is I want to distribute out my 3 here, okay? So I have 3 times 6x, which is 18x. Then I have 3 times 8, which is 24. And uh-oh, now I can see that this is going to be the characteristic of a infinite solution because my variables are the same. I have positive 18x on either side, and I have a positive 24 on either side. So I think that this linear equation matches the characteristics of an equation with an infinite amount of solutions. I wish I could put a picture of Buzz Lightyear here, but I don't want to get sued by Disney. You never know, okay? Even though we're only making like $2 off this lesson, that's okay, okay? So I think my answer is going to be infinite, but I'm still going to go ahead and solve it out. So I'm going to get rid of my constants because I like to do that first. So I'm going to make a 0 by doing my inverse operation, which means I need to do the same thing on the other side to keep my equation balanced. And those cancel out, and I'm left with 18x equals 18x. When I divide to do my inverse operation of multiplication, I'm going to make a 1 here. Those are gone. And now I'm left with x equals x, which means my equation is infinite. No matter what number I put in for x, it will always work. If you got that right, go ahead and give yourself a pat on the back, a little celebration. How about a little party horn? Ah, there we go. Now we're feeling good. Let's go ahead and do our last example. Okay, if you're ready for this one, go ahead again, pause the video, try it. You can push play and check your work. If you're not there yet, that's okay. Go ahead and write it down with me. And obviously the first thing we want to do is we want to distribute out. So I'm going to have 12x plus 12 times 8, which is 96, and that is going to equal 11x minus 5. Now, when I look at this, I see my variables are different and my constants are different. So I think this is going to have a unique solution because it didn't meet the characteristics of a no solution equation or an infinite amount of solutions equation. So let's go ahead and solve it and see if we're right. I'm going to go ahead and get rid of my 11x over here to isolate my variable. And whatever I do to one side, I have to do to the other side. I have now made a 0 here, and I have 1x left over plus 96 equals negative 5. I will now want to isolate my variable by doing the inverse operation of addition, which is subtraction. And when I do that to one side, I make a 0, and I think x is going to equal negative 101. So I'm going to go ahead and write that over here because I still want to do my check, and I don't really have a lot of room right here. So there's what I think x is. Let me get my eraser and erase this, and voila. And so here I have 12 groups of negative 101 plus 8, which is going to equal 11 groups of negative 101 minus 5. When I combine my parentheses first, I'm going to get negative 93, okay? And then I'm going to go ahead and solve this on that side. 11 times negative 101 is negative 1,111 minus 5. Now when I do 12 groups of negative 93, I'm going to get, because I'm doing a positive times a negative, right? I'm going to get negative 1,116, and that's obviously going to equal 1,116, or negative 1,116 when I combine those. And I can see that my equation in fact was balanced when x was negative 101, which means this is a unique solution linear equation. So just to recap really quickly, right? We have a unique solution, okay? And so some linear equations have a unique solution, and that's what most of the time you're going to be dealing with, okay? We have a no solution sometimes for our linear equation, and when that's the case, our variables will be the same, and our constants are different. So there's two different things that are going to make a equation a no solution equation, right? So variables are the same, but constants are diff, as the young kids are saying. And then we have our infinite solution, just like Buzz Lightyear, okay? And if it has an infinite solution, that means the variables are the same, and the constants are the same, right? So my constants and my variables are the same. Wow, that is great handwriting. So that's kind of the recap really quickly of what you learned in this video. You solved a couple questions. You did some awesome stuff. Thank you so much for checking out InstructaBeats in our linear equation playlist. We have one more lesson for you after this. Please tune in and check it out. As always, please like and subscribe our videos. Thank you so much for spending your time with us. Follow on Instagram at InstructaBeats. InstructaBeats out.